Welcome to our demo. Core stateless active queue management exploits the benefits of programmable data planes to expand traffic management capabilities. It performs packet marking at the network edge and stateless AQM in the core of the network. Its AQM component was already implemented in programmable hardware, but the DPDK packet marker still required CPUs. We simplified our packet marking algorithm for P4 Tofino. We use the built-in rate measurement and convert the rate to an index using a logarithm table. By using another logarithm table and the subtraction, we generate random numbers between 0 and the measured rate. Finally, we take the packet value to mark from policy function table. We run 35,000 marker instances in parallel. In our testbed, we perform both CSAQM packet marking and AQM for 100 gigabits per second bottleneck within a Tofino-based P4 switch. Thousands of UDP flows are generated with DPDK packet GAN. Additional flows are generated on separate machines running IPEF2.
On the top, we can track the throughput of selected individual flows, as well as the average throughput of the DPDK-generated UDP flows. In the middle, we can see the overall drop rate in the AQM and the loss rate of the IPEF-generated flows. We can see how the total throughput is distributed between the classes and the overall input-output throughput of the AQM. We start with 8,000 serial flows with a total throughput of 100 gigabit per second. We see a small amount of drop caused by the virtual queue, but they get a roughly equal share among themselves. This deviation is caused by the sender's uncertainty. Next, we start 2000 gold flow. Now the total input rate is 200 gigabits per second and the bottleneck is 100 gigabits per second, so it causes a much larger drop rate. But we clearly see the configured weighted sharing among the classes, roughly 1 to 3.4. Now we start a gold UDP flow with 50 megabit per second. Because its throughput is well below its fair share, there is no loss, even though the system's drop rate is around 51%. What happens if we start a gold UDP flow with higher throughput than its fair share, let's say 50 megabit per second? Its loss rate is around 58%, higher than the AQM drop rate. Now let's start 10 gold cubic TCP flows. They don't get as much throughput as an ordinary gold flow, but still significantly more than a silver flow. Notice that their loss rate is small. Loss is used as a congestion signal by TCP. On the bottom left, we see the current congestion threshold value, an internal variable of core status AQM, and next to it, the physical queue length, which stays low. We tested our algorithm with 35,000 flows as well, and as we see, although the per flow throughput is very low in this scenario, the desired share between classes is still met.